Hello, this is a video related to basic basics of high performance liquid chromatography, commonly known as HPLC. HPLC or high performance liquid chromatography is an analytical technique used for separation, identification and quantification of a chemical mixture, or simply we can say that it is used for separation of mixtures. HPLC is a form of liquid chromatography. It is also known as high pressure liquid chromatography. HPLC is distinguished from traditional liquid chromatography because its operational pressure are significantly higher, or it may be called an automated version of a liquid chromatography. It may be called is an automated version of liquid chromatography. It is in fact traditional liquid chromatography mechanized to get conditions that provide enhanced separations during shorter periods of time. In high performance liquid chromatography, HPLC, the stationary phase is a solid or a liquid, and the mobile phase is a liquid. The principle of HPLC. Principle of HPLC is based on adsorption as well as partition chromatography. It depends on the nature of stationary phase. If stationary phase is solid, principle is based on adsorption chromatography. If stationary phase is a liquid, then the principle is based on partition chromatography. Or simply the mixtures are separated by using the principles of column chromatography. But in HPLC, highly improved separations can be achieved. In HPLC, higher separation efficiency is achieved by using specially designed columns and high operational pressures of mobile phase. In HPLC, the chromatographic column, which is made up of stainless steel, and it is tightly packed with very small particles as stationary phase. It gives a much greater surface area for interactions between stationary phase and the components or molecules which are flowing through it. This allows a much better separation of components of the mixture. Here in this picture, two columns are there. One column is classical column chromatography and the other is column of HPLC. We already told that in HPLC, columns are packed with small particles. Here you can see that the columns are packed with very small particles as small as 3 to 10 micrometer, and the mobile phase contains components which are to be separated, flowing through this column with high pressures. It is around 40 to 400 bar pressure. This high pressure of mobile phase pass through this column with clear and reasonable flow rate. This makes good separation with short period of time. That is, due to the high pressure of mobile phase with a reasonable flow rate makes good separation in HPLC with short span of time. But in classical column chromatography, the column is packed with large particles having size around 150 to 250 micrometer, and the pressure exerted only by the hydraulic pressure of mobile phase or by the use of low pressure pump. Column chromatography yields separation, but the separation is very poor as compared to HPLC. And this column chromatography is also take long time for separation. On account of the use of high pressure of HPLC, this high performance liquid chromatography is also known as high pressure liquid chromatography. So in high performance liquid chromatography, we get good separation within a short period of time, but within short period of time as compared to normal classical column chromatography. In HPLC, a solvent or a mixture of solvents along the column with high pressure induces a differential distribution of components between two immiscible phases. This in turn induces a differential migration of components along the column and thereby affects separation. This is a picture of simple HPLC unit. Next, instrumentation and flow diagram of HPLC. Here in HPLC, these are the different parts of simple HPLC unit. Here the mobile reservoirs, then solvent filter and degasser unit, solvent mixture unit, then there is a pump, then injection unit and syringe. It is used for the sample injection. Then the main part of this HPLC is column and it is kept in a thermostat, and the other unit is detector part. Then there is an data processor and recorder part. Then the other one fraction collector or reservoir part. So this is the sample. This is the instrumentation or flow diagram of simple HPLC unit. Here in HPLC, the HPLC apparatus is provided with one or more glass or stainless steel reservoirs, each of which contains 500 ml to 2 liter of a chosen solvent. Each solvent is then passed through suitable filters and degassers to remove dust and dissolved gas. That is, this solvent filter and degasser unit is used for the removal of dust and dissolved gas which is present in mobile phase. Suppose we not doing this part, it would interfere the performance of column and detectors. So this solvent filtration and degassing is very important in HPLC. So this solvent filtration and degasser unit is used for purification of mobile phase, simply used for the purification of mobile phase. Then the other part, solvent mixture part. The required composition of solvents or mobile phase is mixed by using solvent mixture unit. The mobile phase, after mixing, the mobile phase is then led to the pump, where it is compressed to the required high pressure. It is in between 40 to 400 bar pressure. Then the sample is introduced into the column along with mobile phase by means of an injector unit or injection unit. The samples which are to be separated is injected by means of a injection syringe. Here a valve equipped with a sample loop of the appropriate size reproducibly injects the required amount of the sample into the flow path. Then the column, it is approximately, it has 10 to 30 centimeter long, and 4 to 10 millimeter inside diameter, and it is made up of either heavy walled glass tubing or of stainless steel tubing. It contains a packing of, say, silica or alumina of particle size 3 to 10 micrometer. It is then kept in a thermostat to maintain the desired temperature for separation. This column is maintained, or it is kept in a thermostat for desired temperature of separation. Differential distribution of sample components between packing material and the mobile phase brings about differential migration of components along the column and thereby affects separation. After emerging from this analytic column, the separated components passed through a detector. The common detectors are based on the measurement of optical absorbance or fluorescence or refractive indexes of the emerging components. Sometimes a combination of different detectors are used. The signal from the detector is analyzed and recorded by a computerized data processor and recorder. Sophisticated data acquisition and analysis systems are available for all detectors. Then here the separated components that emerge from the detector lead into waste reservoirs when the method is used for the analytical purpose. On the other hand, they are led into fractional collectors when the method is used for separation as well as analytical purpose. So this is the instrumentation and flow diagram of HPLC. Here we conclude the things which are discussed in instrumentation or the flow diagram part, or flow diagram the previous slide. Here each solvent is passed through a suitable filters and degassers. Then the second, the mobile phase or the solvent is then led first to pump, where it is compressed to the required high pressure, and then to the chromatographic column. Then the sample is introduced into the column by means of a injection unit through a syringe. Then the differential distribution of sample components between the packing material and mobile phase brings about a differential migration of components along the column and there affects the separation. After emerging from the analytical column, the separated components pass through the detector. The signals from the detector will be analyzed and recorded. The separated components that emerge are led into waste reservoirs when the method is used for analytical purpose. On the other hand, they are led to the fraction collectors when the method is used for separation as well as analytical purpose. So these things are already discussed in the instrumentation part in the previous slide already discussed. So these are the different processes carried out in HPLC. Then what are the different HPLC modes? First, this HPLC can be classified by the phases, that means by the stationary phase or mobile phase. So there are two types of HPLC based on the phases, that is normal phase HPLC. In normal phase HPLC, the stationary phase is a polar part and the mobile phase, that is solvent, it is non-polar. In reverse phase HPLC, the stationary phase is non-polar and the mobile phase is polar. So based on phase, the HPLC is divided into two: normal phase HPLC and reverse phase HPLC. In normal phase HPLC, stationary phase is polar and mobile phase is non-polar. And the reverse phase HPLC, the stationary phase is non-polar and mobile phase is polar. Then based on the operation, the HPLC is classified into two: analytical HPLC and preparative HPLC. In analytical HPLC, no recovery of individual components of substance, and in preparative HPLC, individual components of the substance can be recorded. So in analytical HPLC, we can identify, or we can determine the number of components or number of molecules which are present in the mixture. But by using preparative HPLC, each component or each molecule of a mixture can be recovered or can be analyzed and recovered. So this is the classification of HPLC with different phase and similarly based on the operation. Next, the applications of HPLC. The HPLC is a highly sophisticated technique for the separation of components from mixtures. That's why this HPLC is used for majority of all research laboratories. It may be in biochemical research, it may be in clinical research, it's pharmaceutical research, or doing chemical research. All the applications of HPLC is very vast. Then the major applications are in drug discovery purposes, then in clinical analysis purposes, in proteomic studies, and in forensic laboratories, drug metabolism study, cosmetic analysis, pharmaceutical applications, environmental studies, in chemical and biochemical research, and it is also in food analysis. These are the major applications of HPLC. Then thank you.